This one's even easier. If we just kind of pull up and give it a little wiggle, it pulls right out. And then we've got our hard disk drive out. And I'll put this to the side. We'll move the computer case out of the way. We can talk about these two different drives. Okay, so now that we've got these two drives out, just the very first thing, without talking about either of these drives specifically, is I just think without talking about that we have on both of these, we've got these blue retainers that are what hold the drive into place. And this is something that you'll commonly see inside of cases, is they'll have some sort of special mechanism like this blue one that actually attaches to the drive itself. And this one, it just, on SSDs, if I hold it up close to the camera here, it's actually just held in place by tension, and there's these little pins that fit into the mounting holes on the SSD. It's a very common way. And then on this hard disk drive here, we've got these little slots that hold this in place here, and this is what then allows these drives to be able to adapt to easily be installed into the bays in the case. So let's start by taking a look at the hard disk drive here. So you'll notice, if we take a look, first thing is the capacity. So this is quite a large drive. It is 3 terabytes large. And then if we look down here, you can see that it is a SATA. And we also get this, which is interesting, the RPM. So with hard disk drives, there's actually a disk inside of here that's kind of somewhat similar to what you would think of a DVD or CD. And there's actually something that reads and writes to that disk, and the disk has to spin for that to work. So there's actually moving parts in these drives. So before SSDs, this was kind of the best thing that we had for storage. However, there are some drawbacks to it, specifically that it's much slower for reading and writing because it actually has to spin that drive, and they are more prone to failure because there's of course mechanical parts that can fail or die on these drives. Nowadays, you'll commonly see them used for large storage applications because they're a lot cheaper to get large storage, and for doing things like storing files or things that aren't accessed as frequently on your computer. And it's really common to see a kind of dual drive setup like this one, where you'll have one hard disk drive or maybe even more hard disk drives and then one SSD. So with that being said, let's take a look at the SSD here. And if I pull this one up to the camera here, you can see, so it's much smaller. It's 256 gigabytes, so it's about 1/6 the size of the hard disk drive. And SSD stands for solid state drive, so that means this is not actually a drive that moves or anything like that. It's all solid state in that it uses flash memory, and this makes it a lot faster to read and write from, and it's also a lot more reliable because we do not have any of those moving parts. They are, however, a lot more expensive than the HDDs are, so that's why you'll see a tandem approach where we'll put things like the operating system or any applications that would be frequently accessed or used. We'll put those on the SSD, and then we'll use the hard disk drive to store things like videos or files or things that are less accessed. If you're going to put one thing on the SSD, the best thing to do is put your operating system. One other quick thing I will call out is you'll see here that it gives the dimensions here as 2.5 inch. So that's the standard size for SSDs. You'll usually see them in this 2.5 inch size. And then it didn't actually say it on this hard disk drive, but then these are generally 3.5 inch. You can actually get 2.5 inch hard disk drives as well, but the form factor you'll usually see them in is this one, which is the 3.5 inch. So now that we have an idea about these two different drives and the scenarios we would use them for, I'm going to move them out of the way and we'll take a look at how to install them back into the computer. Okay, so I've got the computer up on the side here, just going to be easier to get access this way. And I'm going to just start by installing these drives here. The first thing I'll do is I'll actually put in the SSD. You'll notice these cables, the way they're routed, they're not long enough to actually plug it in outside and then put it in. So I'll just slot this in first. And then I'm going to go ahead and route this cable through here first so that it's not going to cause us issues later. And then we can just install this one, so it's as easy as just lining it up and then pushing it down for these power supply cables. Make sure I got it on the right side here. Perfect. And then the SATA one is right here, and then this is as easy as just clipping it in. Perfect, and that's all clipped in, so now I can go ahead and use the hard disk drive. Alright, so I'll start by sliding this one in, make sure it's clipped in. And I will do the power here, and I'm going to do this blue one here. Perfect. So now we can just slot this down, and there's a release here, which is holding this in place, which is kind of nice for working on it. I just tuck this back in here. You can clip these down, and that's how we would then go about adding or removing or installing any drives. So the key considerations, of course, when you're going to be looking to install a drive is to make sure that they're actually going to physically fit inside of your case and the drive base, and then also that you've got the open SATA ports or connectors from your power supply to be able to power them. That wraps up this video. I'll see you over in the next one. Welcome everyone. In this section of the course, we're going to be learning about the graphical processing unit, or the GPU. This component of the computer is responsible for actually rendering the graphics and outputting them to a display. If you've ever played video games, then this is a very core component of the computer for those games, as it's responsible for actually generating the images that will be shown on the monitor. Let's hop over to the computer now and take a look at what it looks like inside of the PC.
Hey, how's it going?
So I've actually got my personal computer back here again to start this lesson instead of the desktop we've been working through, that business or enterprise desktop we've been using. And the reason for that is that computer, the business or enterprise one that we've been using throughout this lesson, did not have an external GPU. So this is a GPU in my computer right here. It's got an external one. And you may have actually seen or recalled when we were looking through the CPU specifications, didn't touch on them, but it actually did have some graphical processing capabilities or a built-in GPU to the CPU. And that's actually the case with most modern CPUs these days, is they have a graphical processing unit built into it, and that can actually handle the majority of what a standard user would need to do. So, things like using desktop applications, word processing, even watching videos, going out and browsing the web. All of that can be handled by the internal GPU.
Hey baby, what you doing?
Inside of the CPU itself.
Right now, baby.
However, if you want to start doing things that are more graphically intensive, so in a business example, maybe something like 3D rendering or computer animated design or editing videos, and the GPU that's inside of it or internal to the CPU, it may not be powerful enough. And then also outside of business applications, if you're going to be doing lots of gaming, especially if you want high FPS or frame rates, you're probably going to need an external GPU. So that's why I've got one in this computer. And before I actually go and show how to take this out and how it's powered, I do just want to flip this computer over so we can see its back here. So I'll just flip this case over here. Taking a look at the back of this computer, we're going to talk more about the ports and the peripherals that plug into them in its own separate lesson. But just really quickly, this is the motherboard right here. This is actually the back of the motherboard. So all these ports are actually attached directly into the motherboard. And there's these two right here, which are for hooking up an external display or monitor, the display port and HDMI. And if you look over here, this is actually the back of the GPU, which we're going to pull out in a second. So the GPU is sitting right here. And it actually has some of those similar ports. So it's got a display port and an HDMI here, and then we've actually even got a DVI right here. And the reason I'm showing this is if you're going to be using a GPU like this, where you're adding one to the computer and it's not the built-in one of the processor, you need to be sure to actually use those ports. Now, if you plug your monitor, for example, into the ports on the motherboard, well, you're just going to then be using the actual GPU that's built in the CPU, so you won't get all that extra processing capability. So make sure you're plugging it into these ports for the GPU. That being said, let's take a look at how we can actually take this GPU out. So this is something that's going to really vary depending on cases, but for mine, it has these screws here, so we need to unscrew all these screws. So I'm just going to do that. They're nice. These are thumb screws. I'll have to get that one out with my thumb. And there's two right here. These are actually holding the GPU in place, so I'll just unscrew these. And I'll just flip my computer back on the side gently here. Okay, and then the GPUs, they'll go into the PCI slots on the computer. So that's this slot right here on the motherboard. And we'll take a look actually at those in more in depth once I get it out. But you'll see there's a clip right here that actually holds this in place. So I'll just clip this down.
Watch out, y'all! You going down? Some of ours got
And then
hurt.
the GPU lifts out. And if I just turn this one on its side so you can see here, this is the power supply for it, or this is the power that comes in from the power supply. So we don't have this on our desktop computer, but my power supply, this one's a lot more powerful. It's a 750 watt one, and it of course has lots of extra power cables for running even multiple GPUs off of it. So I'll take this out here again. It's just got this clip here that's holding these in. Perfect, and I've got it out. So actually the majority of this power supply, what's taking up the space of it, is these fans and the heatsink, because it's also very important to keep these cool. So I'll set this to the side and I'll actually take a look at showing you those PCI ports. So I'm back over here at the desktop computer we've been using for majority of the section of this course, just because it's easier to actually see and locate the PCI slots in this computer, and they're down here in the bottom left corner. So these are called PCI Express slots. These ones, that's nowadays what you will generally see as these PCI Express. And they're in two form factors. So we've got this one right here, which is a PCI E16X. So it's kind of hard to see, I'll just zoom in on it. You can see the labeling here. So this top one here is in the 16X form factor, and they've actually got a smaller one here in the 1X form factor. And the PCIe or PCI Express slots, as they're called, are the main expansion slots you'll generally see on a motherboard for adding external components, like for example the GPU that we have. If it were to be able to fit into this case, it's too big to fit in this case, well, it would fit into this PCI slot here. And some other common external components you might add would be things like an additional network card or a wireless card, and those come in the PCI form factor, and they would just slot into here. So if I just zoom out, I'll show you how you would install those on this computer. I don't have one, but I'll give you an idea of how that would work. So on this computer, you lift up this tab here. So generally there'll either be a tab or these will be screwed in. And then we've got these blanking plates here, and if we just pop one out, they just pop out. Then we can just, it's as easy as literally just clipping the card in here, and then it will line up in here, and we just pull this back over, and it will hold the card in place. Some of them will have screws that you can also use as well. On this computer, it's nice, it's just got this clip here that clips them back in. So I'll put the blanking plate back in here. And clip that back up, and that's where we would put any PCI expansion as well. So since the GPU is not going to fit in this computer, what I'll do is I'll just wrap this video up here, and I'll see you over in the next one. Welcome everyone. In this video, we're going to be talking about some of the ports that are actually on the back of the computer and what kind of cables we can plug into them. Let's hop over to the computer now and take a look. So we'll start this lesson by taking a look at the back of the desktop computer we've been using throughout the majority of this section of the course. And what we'll do is we're actually going to walk through the different connections or ports on the back of this computer, talk about what they're used for, and also the cable that they would have plugged into them. And we'll actually be swapping out this computer as well with a couple of other computers, because there are some missing ports or connectors that are not on the back of this computer, but I think you'll still come across quite frequently, so I'd like to demonstrate. So the very first one we'll look at, we've already talked about, and that's this one in the left here that's attached to the PSU. And this is actual power connector for the computer. So this is what we essentially plug into the wall to get the power to the computer. And I've already shown the cable for this, but we'll just slide this out of the way and give it the cable. Okay, so this is the cable, this female end here. This is what plugs into the back of the power supply, and then this is just a standard North American wall outlet receptacle that would plug into the wall. So fairly standard cable. The next one we'll take a look at is this green connector in the top left-hand corner, and this is for a serial cable. This connector is called a DB9 connector, and this is the male end of it. So this would be used to talk serial to different devices. It's a fairly old type of communication protocol. Some of the things that you would maybe use a serial connector to talk to would be something like a modem or a router, potentially to do something like setting it up or configuring it, and also industrial equipment like possibly a PLC or other things that you would see in like a factory setting or industrial setting. This is one of the ones that I don't actually have a cable for, but I do have a USB to serial adapter that'll show what that looks like. So this is a USB to serial adapter. So actually this is the end that would plug into this piece of equipment. Generally the non-computer end, so what if it was like a modem or PLC or something like that, it'll have the female version of that connector, so the one that we didn't have on our computer. So this would plug into that end, and of course this would plug into a computer, but there's also the straight cables that cross over from female to male, so it would have this on one end that would plug into the device, and the other end would be the female version. So you won't really frequently see these in desktop computers anymore these days. The next one I'll show is down here in the bottom left corner here, this blue one. This is called a VGA connector, and this is used to output video to a display like a monitor. This is one of the oldest forms of video connector that you'll most likely encounter today on a computer. And this is a purely analog format of display. So the majority, or pretty much all of the other connectors that you'll see nowadays for sending video are actually digital. And you will frequently not use these anymore except for in legacy situations where you have an old monitor. That's the only connection you have. And that's why they'll sometimes be included still on computers, but they're mostly getting phased out. I actually don't have a cable for this one in my lab here, so I'll just flash it up quickly on the screen to show what it looks like. Generally speaking, if you have an option to use another type of display connector over VGA, then I would recommend using that, as you'll get usually a better display, better refresh rate, less delays. So I brought my desktop computer over here to show a couple of different display connectors that you'll usually encounter. So the first one is this one, which is called a DVI connector. So this was the actual replacement for VGA, or intended to be the replacement for VGA. And this is a digital format of sending video. You can send only video still though, so VGA and DVI, they can only send video, no audio. And the cable for it here, I'll just show quickly. So this is a DVI cable, and you'll notice here this one is actually a dual link DVI. So you can get single link and dual link. Dual link is the upgrade and is able to have higher refresh rates and support higher resolutions. A dual link cable is backwards compatible with a single link connector, but a single link won't fit into a dual link connector, and that's because of the way the pins are oriented on it. So just something to keep in mind. Nowadays you'll generally just see the dual link, but you could run across an old cable that's single link. The next connector we'll show is this one right here, which is an HDMI connector. And HDMI, it can actually send video and audio. It's a digital format. You'll most frequently nowadays see these on things like TVs or home entertainment consoles or gaming consoles. And they're a great choice if you have something that has built-in speakers like a TV. And I'll just show what the cable for that looks like here. So I've got an HDMI cable here to show what that looks like. And on this end right here, this is the standard size HDMI connector. And this is what you'll see on the majority of monitors, computers, gaming consoles, TVs. But I just wanted to show this cable is kind of interesting because there's actually different form factors of HDMI, and you can get smaller versions of it. They're essentially look almost the exact same, but they're just smaller. So there's a couple different smaller form factors that are used, and generally that's just for devices that are very small form factor and don't have the space for the big connector. So just something to keep in mind with HDMI is it has those other form factors. So the next display connector that we'll take a look at is this one right here, which is called DisplayPort. So this is the most modern of all of the different types of cables and connectors for doing video output. It's another digital format, and it can do both video and audio. And if you have an option of all of them, then I would generally recommend using DisplayPort because it's going to support the highest resolution and highest frequency. So if you want to make use of DisplayPort, if you have it on both the monitor and your video card, I recommend using DisplayPort. And we'll take a look at a DisplayPort cable now. So here is a DisplayPort cable here. Both ends of this are the same on this one. And the only key thing that I'll call out for the DisplayPort cable is if you take a look at here, if I can get this in focus, we do have these two pins that are here that are used just to help the cable remain seated in place. And there's actually this little clip here that is sometimes easy to forget about, but you don't want to pull out the DisplayPort cable without depressing this cable because you can damage the connector. So just something to keep in mind when you are using a DisplayPort. And then also, this is one of those ones that I frequently see people trying to plug into the wrong connector because they actually do look very similar to, if I just bring back the HDMI, they actually look pretty similar, so it's easy to get these ones mixed up. So just a heads up for that as well. So I've got a laptop here because there's one connector that's not on any of the desktop computers that I have that I want to show. Because you're going to very commonly encounter it nowadays, and it's going to become even more common. And that is a USB-C connector, so it's right here in the left. And you'll actually notice on this USB-C connector, there is the DisplayPort logo right here. And that's because this USB-C can do video using DisplayPort. And that's one of the great things about USB-C is that it can do things like transfer data, so like a standard USB cable. We can use it actually for charging. A lot of them support charging, and it can also do video nowadays too if it actually has those DisplayPort capabilities. So I've got a couple USB-C cables that I'll show here and we can talk about them. So this is the first one that I have right here, and this is a USB-C DisplayPort adapter in that, so this end is USB-C DisplayPort, and then on this end, this actually just goes out to the DisplayPort, regular DisplayPort adapter. So we would use this if your monitor, for example, does not have a USB-C DisplayPort input, which some of them will, but a lot don't. So you would use a cable like this one, and you notice on this adapter, like it's more or less a straight cable, and that's because it still is DisplayPort to DisplayPort. It's just different pins from USB-C to the standard connector. And then I've got another one right here, and this is actually a USB-C DisplayPort to an HDMI adapter. And you'll notice on this cable, like we actually do have some electronics that are required to do the conversion, because this is not as easy as just a straight conversion of one DisplayPort adapter to another. We're actually using like a whole different protocol for sending that video data. So the last one I've got is actually this one, which is USB-C to USB-C. And this actually came with a monitor that I had that actually had a USB-C DisplayPort in it. So this can actually do USB-C DisplayPort to DisplayPort. But the one thing I will call out just to keep in mind for these is that not all cables can do this. So if you just get, for example, like a USB-C to USB-C cable that came for charging your phone, for example, well, there's a good chance that it's not actually going to be capable of doing DisplayPort. So just something to keep in mind for these. While we're talking about the different video connectors, I've got a handful of video adapters here that I just wanted to show, just to make note of that these can be great for a pinch if you need to convert from different video formats. So the very first one I've got here is this is actually an HDMI, so I'll take an HDMI and then convert that to VGA. And you actually notice, interestingly, it does split out the audio, so you can get the audio out off of a 3.5mm jack. So this is one of those. Here's another one I've got right here. So this is actually an HDMI to a DVI, so we've got an adapter for that. And then I've got another one here. This is HDMI to DisplayPort. And really, you can get all different kinds of adapters for adapting the various video formats. So if you've got a computer that doesn't match up with your monitor, then these adapters can be great. I will say though, as a general rule of thumb, if you can avoid using these, you'll have better video quality, and sometimes these can introduce issues themselves. And personally, also the best rule of thumb that I always try and do is I try not to chain any of these together. So I'll max try and use any of them. So sticking on with USB, actually looking at the back of our desktop now, probably familiar with this connector, one of the most popular, familiar connectors for plugging things into a computer. And this is the USB ports on the back of it. So we've got 6 on this computer. So this connector style right here, this is a USB-A, and we'll take a look at a B as well and a few other form factors for this. But so this one is a female USB-A style connector. And you will notice on this, we've actually got these two that are blue here, and they say SS here, so SS is for super speed, And the blue, that means they're USB 3.0, so they're going to be faster than the other ones. And that's something to keep in mind if, for example, you're plugging in like external hard drive, or thumb drive, or something that you're going to be transferring a lot of data in or out. And it's best to make use of the blue ones so that you'll get transfer speed. So let's set this aside and we'll take a look at some of the different things that we plug into this. So of course this is kind of obvious, but one thing frequently to plug into it, if I've got this mini one here, is a mouse, and this is the male version of USB-A that will just plug directly into those adapters. So one of those common things to probably plug in is a mouse. So the next cable I'll show here is this USB-A to P. So of course this end is the A, and then we've got the male USB-B connector here, and one very common thing you'll see these cables used for is for plugging into printers. So the A here. So there's of course a bunch of other form factors of USB as well. You may be familiar with some of these from plugging in things like your phones over the years. So this is the first one, is one of the older ones, and this is a USB Mini. So this is what the end of the USB Mini looks like. I don't really encounter these anymore, but I remember plugging my first BlackBerry in with this one. And then you still sometimes encounter these. So this is a USB micro here, or micro USB, so what looks a little bit different, a little bit smaller. I still come across phones these days that are sometimes using these phones for tablets. And then, of course, we already talked about USB-C, but I've got a USB-A to USB-C here, so you'll really commonly come across these days, as most devices are transferring over to USB-C. So I brought my desktop here while we were talking about USB, because I wanted to actually show one thing that's not USB, but that we used to actually use to plug in keyboards and mouse, and that's this connector right here. It's called a PS2 connector, so that's PS, and then the slash, and then a 2, so it's not like the video game console. And this is the old way that we used to plug in a keyboard and mouse, and there used to be two of them, a green one and a purple one. So this can either take a keyboard or a mouse, and these are for very, very old school keyboard and mice. And generally the only reason you'll see this, and for example, this is on my gaming PC, is that sometimes people like using the old school keyboards, and they'll only have a PS2 connector on them. So that's what you'll see that for. I don't have a PS2 keyboard and mouse to show, but in case you ever come across that, I just want to show that's what that's for. So the next one we'll take a look at right here is this port right here. So this is for plugging in an Ethernet cable, and this is for the network interface, for a wired network interface. And this actual connection here is called RJ45. So this is an RJ45 port. That's the female end of it. And I've just got a standard Ethernet cable here to show you what that would look like to actually plug into this. So fairly common cable. You've probably seen this. Yeah, the end of this is called an RJ45. So the last ones we'll talk about are these three right here, and they are for audio. These are 3.5 millimeter jacks, and we'll talk about the green one first. It's the most commonly used one. So this is just for audio out, so you would plug in things like headphones or speakers into this one. And we'll talk about this pink one. So this is actually for a microphone in, so you can plug microphones in using a 3.5 millimeter jack if the microphone supports that. And then the last one is this blue one right here. And this is for line in, so this would be potentially for something like if you're recording an instrument. To be honest, I've never used this on a computer before, but that's what that's for. So I'll just bring over actually two of the connectors here so you can see what they look like. So I got a standard pair of headphones here, nothing too fancy about them. And then, so this is what you've probably seen it before, but the 3.5 millimeter jack looks like. And then if I set these to the side here, I've also got this very basic microphone here, and you see it's got this pink jack. So this is what you would plug into the actual microphone. So that almost concludes our lesson here on the different ports and connectors. However, I will say, we covered, I believe, the majority of the most common ones you'll come across. But that being said, there may be connectors or cables or things like that that you come across and you're not familiar with, or you're trying to plug something in and it's not fitting. And for that, I would say Google is your friend. It's really impossible to memorize every single one of them. So if there's something you're not familiar with, then Google is your friend there. With that being said, I'll wrap up this lesson here and see you over in the next one.
Welcome everyone. So we're at another ticket interrupt here, and just a quick reminder for the format of this type of lesson. I'm going to pop up on the screen here an example of a ticket that I've actually received in the past doing help desk or technical support. And we'll go through the ticket itself and read it out. And then what I'll do is I'll throw up a pause here screen. And what I would encourage you to do if you want to follow along is actually just pause the video at that point. Go out and take a shot at solving the ticket yourself, and even if you aren't able to, get all of it or work through it, even just the process of trying to solve it yourself, I think is really valuable. And then when you're ready to, come back and unpause the video and I will go through my solution. So with that being said, let's hop over and take a look at this ticket. Okay, so we get this ticket, computer won't power on here, and the comment says, "Hello, after returning from the weekend, my computer won't power on. When I press the power button, it doesn't do anything. It doesn't make any sounds, and there is nothing displayed on the screen. I can't even try turning it on and off again, so I don't know what to do. Please help." So before I pause it, this is just a little bit different of a ticket interrupt in that, of course, I'm not expecting you to have a computer that's not going to be powering on or anything in this state. What I'll get you to do for this ticket interrupt, and I'd highly encourage you to do, is just open up your note editor or grab a pen and paper or whatever you're comfortable writing with, and just jot down the process that you will go through if you got this ticket and you had to go over to the person's desk and try and troubleshoot this problem. So just create a list of the steps you would take, what you would try, and if you want to, you could even go into more detail and write down why you would be trying those. So pause the video here, and then when you come back, I will go through my solution. Before we actually jump into my solution, I do want to just quickly go over some very general strategies or important points for actually troubleshooting hardware issues. And you can actually take some of these points just in general for troubleshooting things, but I'm going to be specifically relating them to hardware. So the first one is to have a good understanding of what all of the different components inside of a system actually do and what their roles are. And the reason for that is then when we're troubleshooting and we know we get a problem, for example, like in this one we're talking about the power to the computer, but maybe let's also take the example of, say, the monitor won't display. Well, if we think about all the components that are required to make that happen, of course, we know we've got the monitor itself. It has its own power cable. There is a cable from the monitor to the computer. Maybe possibly there's an adapter in line there, and it's going to plug into either an external graphics card or the graphics on the motherboard. And we can think of all of the different components that take place in order for the video to actually go from the computer to the monitor. So having an understanding of those components is key, because now when we have the problem, of course, the monitor doesn't display anything, we can immediately think of all the different problem areas. So that brings us to the second key point I want to talk about when troubleshooting, and that is actually being able to break down those components to kind of the lowest testable parts and being able to isolate those in our testing. So maybe if it's the monitor example, maybe we just test the power cord. So we'll, at a very basic level, we could just take a known working power cord and replace it with the one in the monitor. And if it still doesn't work at that point, well, maybe we try the video cables and so on. And that helps us to troubleshoot because we're just testing one small component at a time. So the final point that I'll touch on is just the order in which you're going to do testing. And one of the things that I'll like to do is I'll try the most basic or the easiest stuff first. And even if it's not, likely to be one of those things, if it's very, very easy or quick to test, then I'll try and start with those just so that we can save time and we're not jumping, to something that takes a lot of time, like replacing a component inside of the computer without having tested the basic stuff. So with that being said, let's hop over and see how I use some of these key principles to walk through how I personally would troubleshoot this power supply. And, this isn't to say this is the perfect way to do it. There could be other steps or a better way even. This is just, my thought process. So the first thing that I would do is I would check the power cable and make sure it's properly plugged in. Of course, that's at both ends, at the end that plugs into the power supply itself and also at the wall outlet. I would also check if it's plugged into a power bar or a power strip of some sort and make sure that hasn't been powered off or reset in some way. And then I would also make sure and check if the PSU or power supply unit itself has a power button or power switch and make sure that's on the on position. So this is here, starting with the most basic and easiest stuff that, this would take like maybe 30 seconds to check all of this. probably then go ahead and just verify the outlet or power bar are actually functioning properly. So one way to do that could be just to plug in a known device to the outlet and make sure it works, and then if that works, maybe plug the power bar in and then plug that device into the power bar. Make sure both of those things are working. So if all of those were working and the computer still wouldn't power on, the next thing I would do is open up the computer case and verify the connections from the power button to the MOBO. So you'll recall there is, of course, the actual wires that run from that power button or the power switch to some pins on the motherboard. What we could do is try unplugging those and replugging them in. And if that still doesn't work, maybe even checking to make sure if there's any damage to the button. And if all that doesn't work, then what I would do is I'd probably take a look at the manual for the motherboard and find out which two pins are actually responsible for being hooked up to the power switch to